dominant allele, it should be the total number of dominant alleles in the gene pool divided by the total number of all alleles in the gene pool. And frequency of recessive allele is the total number of recessive alleles in the gene pool and divide by total number of all alleles in the gene pool. Let's look at this example. A population of diploid organism that consists of 2,000 individuals with a respective numbers of each genotype. So in this example, the number of each genotype are given. Kita ada specific number. So bila ada specific number, we can calculate the specific frequency of each dominant and recessive allele. To calculate the frequency for dominant allele R, first we have to find the total number of alleles in the gene pool. The total number is, since the total number of organism is 2,000, then we have to multiply by 2. Okay? Then we have the 4,000 alleles. The next thing is to find the total number of dominant alleles and recessive alleles in the gene pool. So for dominant alleles, it should be the number of R homozygous dominant individuals times by 2. So we have the 1,960 alleles. While for total R dominant alleles in the heterozygous individu is stated as 840 individuals are heterozygous. So we can only 800 multiply 840 with only 1, because each heterozygous individu carry one dominant allele and one recessive allele. So we can get 180 dominant allele from the heterozygous genotype. So we have to total this up and get 2,800 allele for dominant allele R. Dapat tak semua? Do you understand, everyone?
Understand,
Yes,
madam.
Alright, thank you for your response. Very good. So far, clear? Next, the third step is to find the frequency. So since we have the total number of dominant allele R in the gene pool, then we can put in the value to get the frequency. So it's 2,800 divided by 400, then we have the frequency for R allele is the 0.7. Okay. Next, to calculate the frequency for allele recessive allele, the R kecil, the total number of alleles are the same with before, but the total number of recessive allele would be different in the gene pool. So we can get the R recessive from this individu. So we have 840, and then we have 180 individu with homozygous recessive. Then we have to multiply with 2. 180 multiplied 2 is 360, and then we sum this up, total up the number, then we have the 1,200 amount of recessive allele. Then to find the frequency for the recessive allele R, we have to use the formula. It should be 1,200 divided by 4,000, then we have the 0.2. Since we have already obtained the frequency, then we can try to add up frequency for recessive allele plus frequency for dominant allele. When we sum it up, it should get 1. Okay. 0.73 plus 0.7, then it's equal to 1. Okay, genotype frequency. Tadi allele frequency allele frequency kita akan kira satu-satu allele. But for genotype frequency, we will count the number of the individu. Sebab satu individu ada bawa genotype. Tetapi satu individu akan bawa dua allele. Genotype frequency is the ratio, still about ratio of total number of individuals with a particular genotype to the total number of all individuals in a population. So since we have three types of genotype, we have the homozygous dominant, R besar, then we have the heterozygous, R besar, R kecil, and then we have the homozygous recessive, R kecil. This is according to Mendelian law. Since we have three types of genotype, then we have to remember or memorize the formula. Total number of homozygous dominant individual divide by total number of all individual. Jadi kalau awak tengok ni semua mesti kena bahagi dengan jumlah populasi tu atau individu dalam populasi. With the same value that we have used before, with same value dengan bilangan yang sama. Kalau tadi kita kira berapa bilangan allele setiap satu. Now we are going to calculate the genotype frequency using the number because we have three types of genotype. So if sexual reproduction occur at random, then we have to calculate the frequency for the homozygous dominant, the R besar, heterozygous and the homozygous recessive. So basically, because we have 2,000 individu, and then to calculate is very easy. For homozygous dominant, R besar, kita ada bilangan dia 980. Then we just use the value and get the value that we are going to calculate the homozygous dominant frequency. Tak perlu tambah, tak perlu kali, tak perlu bahagi. Tak perlu darabkan dengan 2 ke apa sebab dia dah memang bilangan individu. Jadi untuk calculation to find frequency for homozygous dominant, it's 980 divided by 2000, 0.49. And then total number of heterozygous is this one, 880 divided by 2000, then we get 0.42. And then homozygous recessive is 180 divided by 2000. So the value is 0.09 for frequency of homozygous recessive. So it's a very straightforward because we know the number of each genotype in the population. Jadi gunakan je direct, senang tak? Siapa kata susah? Boleh bagi tahu kat saya. Okay, the concept yang kita kena faham. What is genetic equilibrium? Konsep yang kita kena faham in a population that is in genetic equilibrium. Equilibrium maksudnya keseimbangan, keseimbangan, or in a similar word we can use balance or stable. Okay. The condition of a population which allele frequency and genotype frequency remain constant. That is genetic equilibrium. So from generation to generation, kena faham konsep generation. Mak ayah kita generasi satu, kita generasi kedua, dan anak kita will be the third generation. So the condition of a population in which allele frequency and genotype frequency remain constant from one generation to the next. Contoh saya bagi bilangan untuk satu kelas yang ada 10 orang. Bilangan lelaki mungkin 1 daripada 10. 1 daripada 10. Jadi dia adalah 0.1. Katakan the next generation, bilangan total populasi menjadi 100. Jadi bilangan bilangan lelaki sepatutnya apa kalau dia remain constant?
10.
Yes, very good. It should be 10 over 100. So kita akan dapat nilai yang sama dengan 0.1. So as the population number increase, the number of that particular genotype or allele should increase. Okay, mesti sekali dengan peningkatan, setara dengan peningkatan bilangan populasi. So this type of population that reach genetic equilibrium is said to be not evolving. Evolving ni evolusi lah, berevolusi. Dia punya tak ada perubahan dalam dia punya populasi. So lepas ni kita akan belajar. We will learn what does it mean with non-evolving population. Okay, ada soalan sebelum saya teruskan kepada the next. So let's continue with Hardy-Weinberg law. So Hardy-Weinberg law, for this subtopic, we are going to learn about the Hardy-Weinberg law and the 5 assumptions that Hardy-Weinberg law said for a population to reach genetic equilibrium. Then we are going to calculate the allele and genotype frequency. First, Hardy-Weinberg law explained that a population that exists in genetic equilibrium, the alleles and genotype frequency must remain constant from one generation to the next generation. So this can only apply to the population that the individuals reproduce sexually, secara seksual. Sebab kalau asexual, dia dah tak ada gabungan genetik, dah tak ada share sana share sini tau. Dia dah automatic dia akan bagi berlaku secara asexual tu dia akan serupa dia punya kandungan genetik. Jadi tak ada recombination kan. So Hardy-Weinberg law is used in a population that is not evolving, that reach genetic equilibrium. So not evolving is equal to ataupun similar dengan bila orang kata in genetic equilibrium. So to reach genetic equilibrium, there are 5 conditions that must be met by the population itself. So kena ingat, this one you have to memorize, these 5. Extremely, the population must be large population size, an extremely large population size. Nanti kita akan, I will explain later what does it mean with large population size, why random mating is important. The second is random mating, maknanya persenyawaan secara random. Then no mutation, no migration or no gene flow. Sama, bila jumpa no gene flow, it means there is no migration. Migration ada dua, either emigration, going out, or immigration, going in. No natural selection. Let's look at the explanation. In an extremely large population size, any minor change in the frequency of alleles will not be significant. Maksudnya tidak akan perasan. Contoh kalau satu populasi yang 1 juta, kalau hilang 1 orang, boleh perasan tak? Berbanding dengan kalau populasi ada 10 orang saja, seorang hilang kita dah boleh perasan kan? Ada tinggal 9 orang saja. Am I right?
Right.
Betul tak?
Yes.
Okay. So, extremely large population size, we can just ignore. The minor change can be ignored. So, it is not significant lah, minor change. Maksudnya, perubahan yang kecil. In small populations, any genetic drift ni a process in which the chance of events that cause unpredictable fluctuations in allele frequency. Unpredictable fluctuations ni maksudnya changes lah, perubahan dalam frekuensi allele akan ketara. So extremely large population size is very important. For example, dalam generasi 1, in this generation, the highlighted plants leaf offspring, in this original population, the flowers, the red flowers, white, and a few pink flowers left the population. Jadi bila dia tinggalkan populasi tu, it acquire some new places and they interbreed at that new area. Dia akan bermandiri, survive dekat kawasan yang baru. Kemudian dia akan hasilkan satu populasi baru dengan takungan jin yang berbeza. A very different gene pool. Kemudian apabila the next generation, the red color only left the area, the second generation, to form a third generation. Jadi dalam generasi ketiga ni kita nampak dah tak ada variasi dah, hanya ada warna merah sahaja. Jadi kat sini dah berlaku, this is what we call as genetic drift. Another example, when we have 10 rabbits, with 10 rabbits, 8 out of 10 are brown color and the other 2 are white color rabbit, white color fur. So amongst the brown rabbit there are heterozygous here, heterozygous, and there are homozygous recessive. So if 5 out of 10 rabbits leave the population and then reproduce among themselves, ini sebab tadi ada among 5 there are heterozygous rabbit. So there are still white rabbit will show in the next generation. But if the next time for the next generation only the homozygous dominant interbreed among themselves, then we will the recessive allele will be eliminated in the next generation. Jadi kat situ dah berlaku perubahan pada takungan jin. The gene pool has been changed. Then the second assumption or condition that should be met for a population to be in equilibrium is random mating. So for random mating, individual should not pick mates. Dia tak pilih. This usually happens in the ocean. Contoh dalam ocean, dalam laut. In the ocean, the coral polyps, coral polyps ni adalah batu karang jenis polyp. They produce sperm and then release into the ocean. So the sperm did not choose any particular ovum to fertilize. So the fertilization occurs at random, by chance. This is what we call as random mating. So Fatihah, do you think human undergo random mating or not? Fatihah Rizwan, don't Fatihah. In your opinion, are we human do this random mating? Nur Fatihah, Muhammad Rizwan. Nur Fatihah ada tak ni? Nur Fatihah tak ada? Saya tanda tak ada ke? Dia di toilet ke? Ataupun dia check. Saya kena check dekat chat. Tak ada. So Nur Fatihah tak ada. Kita minta Afzan. What do you think, Afzan? Afzan from H2T4.
We as a human, no random mating, I think.
Why do you think we do not apply random mating?
Because men have
because we choose our own mate.
Our own.
Yes, of course. Usually we choose. We didn't do this random mating. It's like you close your eyes and then pick whoever pass by, and then okay, I will marry you. No, that's not how we get married, kan?
Yes.
Biasanya kita ada pilihan, kita nak orang macam mana, kita nak ciri-ciri macam mana, nak yang beriman lah apalah kan, nak yang tinggi ke rendah. So we do not random mating does not apply to us human. It usually apply to animals. So if individual tend to choose mate like us, with certain genotype, for example, we choose a short person compared to a tall person, then the gamete, the characteristic will be not random. The gamete will not fertilize randomly. So then the genotype frequency might change. Ya. Kita mungkin akan mungkin makin lama kita tak jumpa orang yang tinggi contohnya, ataupun kita pilih orang yang rambut kerinting, kemudian nanti lama-lama orang yang rambut lurus dah tak ada. Itu contoh This example shows a large blister beetles tend to choose mates of large size. The large beetles mate with large beetle, and small beetles tend to choose the small mates. This will result in fewer heterozygous. Jadi gabungan allele tu dah berkurangan sebab yang kecil dengan kecil, yang besar dengan yang besar. This population, the mating is not random. Okay, the third assumption is no mutation. If there is mutation, the gene pool would be modified, especially if the entire genes are deleted or duplicated. Hilang. Kalau hilang, nanti awak akan belajar tentang mutation. But for the time being, you have to understand, if there are mutations, some changes of the genes will occur. If the genes are deleted, then we will not see the gene in the next generation. Any mutation would change the balance of the alleles in the gene pool. For example, this diagram shows the original character is having a long antenna, and then mutation occurs cause producing beetles with a short antenna. Without mutation, the composition of the gene pool will remain the same generation after generation. When mutation occurs, there will be change in the allele frequencies. Next is no migration or no gene flow. The gene flow refers to the loss or gain of alleles in a population. Kehilangan atau mendapat pertambahan, kehilangan atau pertambahan alleles in a population due to migration of fertile individuals between population. Migration can be emigration, as I said before, either going out of the population, keluar, emigration, E for E for exit, and immigration for going into the population. Macam kita terima kita ada rakyat kita yang migrate keluar, jadi dia ambil kerakyatan baru dekat negara lain, pindah ke New Zealand for example. Jadi kita kehilangan rakyat, ataupun kita terima kehadiran rakyat yang baru. So for the allele frequency to remain constant, no new alleles should move into or out of the population. Tak sepatutnya ada yang keluar atau masuk. Kalau tidak akan berlaku perubahan lah. Sebab yang masuk kemungkinan bawa allele yang berbeza daripada allele yang sedia ada dalam populasi. Ataupun populasi kita yang ada dalam keluar dan kita kehilangan allele tersebut. Okay, it will alter the allele frequency. Okay, the last one is no natural selection. Pemilihan semula jadi. No natural selection. What is natural selection? So natural selection is actually the survival and reproductive success of individuals due to adaptation to environmental change. Contoh, I give you an example. If our climate become hotter each year, semakin panas, so there will be some individu that will not that will succumb to the situation, meaning they will not survive. They might die due to the inability to sustain the climate change. Tak tahan panas, kulit terbakar, and then there are individu that will survive the change of temperature ataupun climate because they have the ability to produce a melanin dekat kulit dia kan, dekat kulit dia ada produce melanin, hasilkan melanin, jadi kulit dia tahan terhadap kepanasan matahari. So there will be elimination of few individuals that cannot adapt to the change of the environment. Jadi itu adalah contoh natural selection. So for a population to be in equilibrium, all members of the population should survive at equal rates. Di orang yang kulit mungkin cerah dan kulit gelap ni sepatutnya bermandiri. Survive means mandiri, bermandiri pada kadar yang sama. Kalau orang yang kulit cerah boleh lahirkan anak 20 orang dalam masa setahun, sama juga dengan yang kulit gelap, itu maksud dia. So no alleles are selected over other alleles. Look at this example. If resistance to a particular herbicide allows weeds adalah rumput kan, ataupun tumbuhan liar, to live in an environment that has been sprayed with that herbicide, the allele for resistance may become more frequent in the population. Maksudnya, the weeds that has no gene to resist the herbicide, they will die because of the herbicide. And that the presence of herbicide, the spraying of the herbicide is the change in the environment. So those plants, those weeds that cannot resist the effect of herbicide will die. Jadi in the next generation, only allele for resistance will appear in the population. Okay. If there is no selection, maksudnya tak ada, kalau tak ada spraying of the herbicide, both types of plants or weed will survive and reproduce. If there is selection, some of the weeds will be eliminated from the population. Okay, now we have come to the Hardy-Weinberg equation. There are two equations that we should memorize. The first one is the equation for allele frequency. The P plus Q equal to 1. So the sum of all allele frequency, the P and Q, must equal to 1. Meaning that the value of P and Q should be less than 1. Less than 1. Less than 1. It should be less than 1. P is dominant allele frequency, while Q is recessive allele frequency. The second equation is for genotype frequency. Tadi allele, this one is for genotype frequency. For genotype frequency, the P square, the sum of P square plus 2PQ and Q square is equal to 1. So P square is the homozygous dominant genotype. The 2PQ is the genotype for the frequency for heterozygous. The Q square is the frequency for homozygous recessive. And the sum of all genotype frequency must equal to 1. Let's try. Now, together. Sekarang ni yang saya suruh bersedia dengan kertas dan pen dan juga calculator bersedia. Question 1. I will call a few names to answer the question to give the value. Question 1. The allele for black coat is recessive to the allele for white coat. So, can you calculate the frequency of heterozygotes in this population? To help you first, kita tengok dulu. What is the total number of this population?
20.
Kira betul-betul 20
20.
1, 2,
Salah.
4, 5, 6,
16.
16.
Sorry,
Thank you, very
madam.
good. Right. So 16. So the total number of the population is 16. Can you calculate the frequency of the heterozygote in this population? Balkis, boleh tak Balkis? The black coat is recessive to the allele for white coat. Kita gunakan huruf white.
Madam,
White is dominant over black. Yang kita nak cari adalah genotype mana satu? W besar atau W besar W kecil atau W kecil W kecil. Yang mana satu kita nak cari? Dah dapat dah Balkis?
0.25 ke?
Okey. Saya pun rasa betul. Kita tengok betul ke tak? First, we determine how many of the sheep are black. So, from the diagram, from the picture, kita ada 4 yang hitam kan? Because why? Kita nak identify, kita tak tahu. Do we know how many them W besar berapa? W besar W kecil berapa? Dengan W kecil berapa? Kita tahu tak?
Tak tahu.
Tahu tak? Tak tahu. Sebab tak tahu ni lah kita kena guna Hardy-Weinberg equation. Kalau kita tahu, kita tak payah dah guna P campur Q sama dengan 1 ni. Kita akan kira macam mana yang saya ajar tadi. Berapa R besar tadi, berapa R besar R kecil kan. Kita kira macam tu terus. Since we do not know the exact number for each genotype, then we have to use the Hardy-Weinberg equation. So how do we do this? Kenapa? However, some of the individuals with white coat may also carry the recessive allele. Yang putih ni ada yang heterozygous, ada yang homozygous recessive. Ni total dia berapa? Jadi kita tak tahu berapa exact allele, the number of allele dominant allele and recessive allele. So the number of recessive alleles cannot be estimated simply by looking at the homozygous recessive phenotype. That was why we can determine the frequency of allele and genotype using Hardy-Weinberg equation. Okay, let's count it together. Since 4 out of 16 individuals show the recessive phenotype, then recessive phenotype ingat tak tadi? P square campur 2 PQ campur Q square sama dengan 1. Jadi recessive phenotype ni yang mana satu? P square ke 2PQ ke Q square Balkis? Recessive phenotype mana? Yang Q square ke P square?
Recessive genotype. Q square.
Okay, good. So we have to find the Q square. Sebab kita dah ada nilai 4/16 ni. So find Q square, the frequency of homozygous recessive genotype. So by calculating the proportion of the individuals that are homozygous recessive to the total population that they represent. So this is the Q square value. Q square value is 4/16, which is 0.25. Ini baru homozygous recessive. Okay, homozygous recessive. Soalan tadi nak apa Balkis?
Heterozygous.
Ya, soalan nak heterozygous. Jadi awak rasa jawapan awak betul tak?
Salah.
Okay, jadi kita tengok ya. Since we have obtained the Q square value, then we can find the Q value, the frequency of recessive allele. Sebab kita dah ada Q square. So we just square root of the Q square value. Frequency of homozygous recessive genotype is Q square equal to 0.25. Then we get the value of Q equal to 0.5. Nampak tak? Tadi Q square sama dengan 0.25. Jadi Q sama dengan square root of 0.25 equal to 0.5. Okay, siapa tak dapat part ni?
Saya tak faham balik.
Yang mana? Tak faham.
Kan kita dapat apa 0.2, kita dapat
0.25.
0.25 punya ni kan.
Hmm.
Time nak kira ni, apa recessive ni.
Recessive allele. Yang kita dapat tadi, genotype frequency of homozygous recessive. Ya tak? Homozygous recessive adalah Q square. So recessive allele frequency is Q. Jadi nak dapat Q daripada Q square ni, this is mathematics, am I right?
Yes.
Jadi awak dah dapat Q square, awak nak dapatkan Q, mestilah awak square root kan, betul tak? Ya, betul tak? Tahu kan maksud square root, tahu kan?
Tahu.
Itu sebab awak kena faham apabila allele P ataupun Q. Tapi bila genotype dia mesti P square. Dia P darab P. Q darab Q. Dia akan jadi Q square. Ingat tak matematik belajar P campur Q sama dengan 1. Kemudian kalau kita square kan, ini apa ni? Persamaan apa ni? Bila kita square kan kita dapat apa? P square campur 2PQ campur Q square sama dengan 1. Betul?
Betul.
Okay, sama tak? Sebab tu konsep dia Q square adalah Q darab Q. Sebab satu allele, satu individu ada 2 allele. Jadi kita bukan kali dengan 2, kita kali untuk nilai frekuensi. Sebab ni frekuensi kita kena squarekan dia. Squarekan dia, jadi Q square. So bila dah dapat Q square, kita akan dapat nilai Q. Square root kan? Faham tak?
Okay, faham madam.
Alright. So since we have obtained the Q square, saya ulang balik. Q square is equal to 0.25. So we should be able to obtain the frequency of recessive allele, which is the Q. To obtain the Q value, we need to square root the Q square, then we have the Q equal to 0.5. Ini baru dapat Q sama dengan 0.5. Masih belum menjawab soalan tadi. Sebab soalan nak frequency of heterozygous. Jadi frequency of heterozygous is 2PQ. Kita dah dapat nilai Q kan? Kita belum dapat nilai ni. Kita kena carilah nilai P. Betul tak? So next step, next step we need to find the value of P, which is the frequency of dominant allele. We can use the formula of P plus Q equal to 1. Then put in the value of Q that we obtained earlier. Since we get Q equal to 0.5, then P is 1 minus Q. Okay, P is equal to 1 minus Q, which is 0.5. Okay, boleh faham? Siapa tak faham? Macam mana dapat P? Apa yang mengelirukan?
Formula ni memang tu madam.
Ada 2 formula je. P campur Q sama dengan 1 untuk allele. This one is for allele. Nampak tak? Kita sebut dia recessive allele atau dominant allele saja. Tapi kalau genotype kita ada P square campur 2PQ campur Q square. Sebab genotype kita ada 3. Genotype homozygous dominant, heterozygous and homozygous recessive. Betul? Faham?
Maksudnya kalau recessive allele guna formula yang P square campur 2PQ yang tu.
Bukan, itu untuk macam ni. Sebab tadi soalan dia bagi tahu bilangan kambing tadi. Nampak tak? Bila kita ada bilangan individu, kita boleh equalkan dia dengan frequency of genotype. Satu individu ada genotype. Dalam satu genotype ada 2 allele. Jadi kita tak boleh terus dapat nilai frekuensi allele. Kita kena guna frekuensi genotype tu dulu. Barulah kita boleh dapat frekuensi allele. Sebab nak jadi genotype kena ada 2 allele.
Oh, faham,
Okay?
faham.
Tu sebab kita terus gunakan value Q square sama dengan 4 sebab tadi ada 4 ekor kambing yang hitam. Ni 4 ekor kambing hitam ini bawa genotype homozygous recessive. Kalau putih kita tak boleh guna yang putih P square, tak boleh sebab white phenotype P square campur 2 PQ campur Q square sama dengan 1. So, for P square plus 2PQ ni adalah dominant phenotype. Betul tak? Which is the white. Sebab tu, Q square dia adalah recessive phenotype. The black sheep. Okay. Jadi sebab tu, selamat apabila kita gunakan 4/16 equalkan kepada Q square. Berbanding kita nak P square campur 2PQ sama dengan 12/16. Yang mana mudah? Q square equal to 4/16 ataupun P square plus 2PQ equal to 12/16. Bagi tahu saya. Dah pening dah.
Yang Q squared equal to 4/16 lagi senang.
Lagi senang sebab P square campur plus 2PQ equal to 12/16. Kita kena cari dua nilai P, Q. Macam mana nak buat persamaan P square plus 2PQ equal to 12/16? Then it would be a very mathematics lah. Nanti awak dah masuk lah persamaan apa dalam matematik tu. Jadi yang mudah ialah Q square equal to 4/16. And we will directly get the value of 0.25. So since we can get the value of Q square, then we can get the value of Q because Q square equal to 0.25. Then we square root the value to obtain the value of Q. Kan? Dia macam bila belajar bio masuk equation matematik tu dia macam dah tak boleh nak digest. Seolah macam tak pernah belajar matematik. Padahal ni lah yang dia belajar selama ni dekat matematik tu. Okay, bila aplikasikan je awak jadi mudah keliru. Right. Tak apa, nanti kita tengok, bila kita tengok few types of question, kita akan biasa dengan dia punya konsep yang dia tekankan. Sekarang ni mungkin sebab awak baru diperkenalkan dengan topik dan calculation ni Back to the step 2, since we have already obtained Q equal to 0.5, then we can use the P plus Q equal to 1 to obtain the value of P. Alright, use the formula. Using the formula, we just minus 1 minus Q, then we get the value of P equal to 0.5. Jadi sekarang kita dah ada nilai P, Q sama dengan 0.5. Jadi sebabkan tu kita dah ada nilai P dan nilai Q dan soalan tadi minta kita cari genotype heterozygous. Sebab disebut heterozygote kan. Jadi dah dapat for frequency of heterozygous is 2PQ. Jadi dah dapat nilai P, dah dapat nilai Q, masukkan je lah. Use the value. Frequency of heterozygous genotype 2PQ. Masukkan nilai P dan Q, kita akan dapat 2PQ sama dengan 0.5. Nampak tak macam mana kita dapatkan nilai Q, nilai P. Jadi this is Hardy-Weinberg problem. Kenapa dia jadi Hardy-Weinberg problem? Sebab persoalan tentang populasi ini adalah disebabkan oleh kita tak tahu bilangan yang tepat untuk setiap genotype. We do not know the exact number of each genotype. We have 3 genotype. We should have 3 genotype: homozygous dominant, homozygous recessive, heterozygous and homozygous recessive. Atau dalam kes shape soalan ni tadi, WW besar, homozygous dominant, heterozygous, and then homozygous recessive. So the problem stated in the question did not give us the exact number of each genotype. That was why we use the Hardy-Weinberg equation. Ingat Hardy-Weinberg equation hanya akan digunakan jika kita tak tahu bilangan yang tepat untuk setiap genotype. Faham tak? Nak saya ulang balik? Persamaan Hardy-Weinberg kita akan guna apabila kita tak tahu bilangan yang tepat untuk setiap genotype. Another thing that I want to remind you is the value of the frequency. Frequency ni kita boleh tukar kepada value of percentage, kepada bentuk percentage. 0.5 kalau kita tukar kepada bentuk percentage, dia bersamaan dengan 50%. 0.1 what happened to my pen 0.1 dia akan bersamaan dengan 10%. Sebab tu bila kita dapat nilai, sebab tu that was why question can also ask you to give the answer in percentage form. Jadi kalau if the value of Q allele frequency is 0.5, maksudnya dalam populasi itu ada 50% allele recessive dan 50% lagi adalah allele dominant. Separuh-separuh. Itu maksud dia. Okay, cubaan kedua. Kita cuba yang kedua, soalan kedua. Dah bersedia? Bersedia, saya bagi masa. A farmer has 2,000 goats. Saya bacakan dulu. 1,500 of the goats are brown coated and the rest is white coated. Allele A dominant is for the brown coat, while allele A recessive is for white coat. Then you should calculate frequency of dominant and recessive allele of the population. Next, determine the genotype frequency of homozygous dominant and heterozygous goats in this population. Okay, first find the frequency of dominant and recessive allele. Ada dua benda. Next, when you have obtained the frequency of dominant and recessive allele value, you should determine the genotype frequency of homozygous dominant and heterozygous goats. Okay, bersedia? Saya bagi masa 5 minit untuk dapatkan nilai yang pertama dia minta, iaitu calculate frequency of dominant and recessive allele. Nanti saya akan panggil Siti Nur Aisyah Abdul Aziz untuk bagi tahu apa jawapan yang awak dapat. Ya, Siti Nur Aisyah, boleh tak? Siti Nur Aisyah, please.
Ya, madam. Untuk dominant 0.5.
Okey, Siti dapat, Aisyah dapat P equal to 0.5 Masya Allah, apa boleh jadi satu kan. Okey, yang lain dapat sama dengan Aisyah tak?
Dapat.
Sama So kalau frequency of dominant allele 0.5, recessive allele must be the same kan? Sebab tambah dapat 1. Kita tengok First, identify the population size. Tengok steps dia. Second, find the number of recessive homozygous individuals. Right. Jadi kita tengok satu-satu. The population size is how many? 2,000. Betul tak? Sama tak? Dalam soalan ni kita dapat dalam soalan. So, find the number of recessive homozygous individual. Berapa? Recessive homozygous individual berapa? Siti Nur Aisyah, macam mana awak kira ni? The number of recessive homozygous berapa?
Apa madam?
The number of recessive homozygous berapa?
Um, 500/2000.
Okay, the number of recessive homozygous is 500. Kita dapat sebab kita subtract 2000 with 1500. Kita dapat 500 So kita dapat 500 recessive homozygous. Next, divide the number of individuals with the recessive trait by the total number of individuals. So kita akan bagikan 500 dengan 2000. Then we get the value of Q square. So nilai 0.25 adalah Q square. Right? Yang ni kita baru dapat homozygous recessive individual. To obtain the value of P, the next is to obtain the value of Q. To obtain the value of Q. Then we have to square root the Q square. Then kita dapat 0.5. Seperti yang Aisyah maklumkan tadi. The value, betul lah tadi dia kata dominant allele recessive is 0.5. Jadi Q kita dapat 0.5, then we can calculate the value of P using the formula P plus Q equal to 1. So P is 1 minus 0.5 and P is 0.5. Tahniah, tepuk tangan. Bagus, alhamdulillah. Ada siapa yang tak dapat siapa yang tak dapat calculate, tak dapat value yang sama, boleh angkat tangan tak? Yang tak dapat value yang sama, angkat tangan boleh? 1, 2, 3, oh semua dapat. Very good. This is amazing. Next, what should we do? Since P and Q is known, kita dah tahu nilai P dan nilai Q. Now we can use this value to solve the second problem in the question for 2PQ and P square. Sebab soalan tadi dia nak apa? Dia nak heterozygous and homozygous dominant genotype. So frequency of heterozygous genotype, use the value of P and Q in the equation, then we can get 2PQ equal to 0.5. Okay, dapat semua. Siapa yang tak dapat, siapa tak dapat boleh respon? It's good, dapat jawab. Right. Okay, untuk soalan 3. Okay, soalan 3. A locus that affects susceptibility to a degenerative brain disease has 2 alleles, A dominant and A recessive. In a population, 16 people have genotype AA, homozygous dominant, and 92 have heterozygous, while 12 have homozygous recessive. Is this population evolving? Dia tanya pula, ni evolving ke tak? Jadi nak tahu evolving ke tidak, sebab dia dah bagi exact number. A besar berapa? Heterozygous berapa? Homozygous recessive berapa? Jadi kita boleh kira. Kita akan kira dulu ikut genotype frequency yang dia dah bagi. Okay, kita tengok So since we have this exact number, we can calculate and obtain the value for each genotype frequency, and thus we can obtain the value of allele frequency berdasarkan kepada nilai ni. The total number of alleles are 240 alleles. Ni sama dengan, ini jumlah atas ni, kita dapat 120. Sebab tu bila kita dapatkan gene pool, it should be 240 sebab kita darab dengan 2. For frequency of recessive allele, jadi kita kira macam mana? 12 kali 2 campur 92. 12 datang daripada mana? Kita tengok balik, 12 datang daripada this one. Kita tambah dengan yang ada pada heterozygous. Jadi kat sini kita akan dapat value 0.48. So this is Q. Q equal to 0.48 ataupun kita frekuensi, kita tak guna Q lah sebab Q ni untuk Hardy-Weinberg. Jadi kita akan kita akan frequency of A allele. Kita akan gunakan ayat penuh. Frequency of recessive allele is 0.48. While if the population were not evolving, kita nak tentukan. Bila not evolving, tadi kita dah dapat recessive allele. Frequency of recessive allele is 0.48. Sekarang ni bila kita guna Hardy-Weinberg, kita dapat tak nilai yang sama dengan 0.48? Kalau sama, then dia not evolving. So kalau dia tak sama, maksudnya dia sudah evolve. Maknanya ada berlaku perubahan pada allele frekuensi. Sebab tu kita akan guna frequency of homozygous recessive macam yang kita kira Hardy-Weinberg tadi. Q square is 12/120 kan? Dapat 0.1. So square root Q square tadi kita akan dapat nilai Q equal to 0.32. Jadi tadi kita dapat berapa? 0.48. Tapi bila kita kira menggunakan Hardy-Weinberg, kita dapat lain. 0.32. So this shows that from the calculation, frequency of recessive allele is not equal to Q. Tak sama dengan nilai Q daripada penggunaan Hardy-Weinberg equation. So we can conclude that this population is evolved. Dia dah berlaku perubahan pada frekuensi allele. Faham? So in conclusion, for today's apa yang saya ajar petang ni, jadi secara kesimpulan untuk hari ini berkaitan dengan Hardy-Weinberg equation dan juga calculation of genotype frequency. If you were not given the exact number of each genotype, always use the Q square value to start the calculation. Dapatkan nilai Q square dulu sebab itu yang paling selamat because it can be equal to Q square. Kalau you gunakan yang phenotype dominant, you kena equalkan dengan P square and 2PQ. Okay? Jadi from the question, start identify, determine the number. You have to determine the number of individuals with homozygous recessive dulu. Okay? Determine the number of individuals with homozygous recessive. That is the safest way to calculate. And for decimal points, usually if population size is around 100, then you can use 2 decimal points. If population size reach 1,000, you should use 3 decimal points. If it is not stated in the question, kalau soalan dia tak nyatakan use for question must use up to 3 or 2 decimal points, secara common sense ataupun secara hukumnya kita akan gunakan hukum ini. Kalau if population size reach 10,000, then we should use 4 decimal points sebab nanti kemungkinan ada 0.00001. Jadi kena ada 4 decimal point. Kalau tidak nanti jadi kosong saja.